We went from what components make up an atom, how they're arranged, and then how they bond. And we talked about there's going to be two ways that they bond. The first way that we talked about was covalently bonding. So I'm going to want to check out people's drawings, what that might look like.
Strong component have two bonded water molecules.
Remember, water molecule has 3 atoms in it. 2 hydrogen atoms and 1 oxygen atom. Yeah. Yeah, we're getting there. That's fine.
Wait, 2 hydrogens?
Huh? There's 2 hydrogens.
Sounds like a C. What's wrong with that?
Yes, like that.
Like this?
Yeah, that looks good. That looks good.
Like this? Is that what beautiful or?
It's
You
close.
have
Like
one.
this?
Wait, 2 hydrogen and 1.
Me right in the
Yeah, and 1 oxygen.
It's all right. Like this. I just redid mine.
You're 8.
Yes. H2O. We know
That's
that.
funny.
We know from experience. We've been looking back at water molecules. I don't know how many times this year, but we've looked at them a lot. We know that it goes something like this, right? There's a hydrogen, and then there's an oxygen.
Oh, I did it.
And somebody in here thought it looked like Mickey Mouse the other day.
I just
And we know that hydrogen separately has 1 electron.
Oh, no.
And there's 2 hydrogens, so we've got 2 hydrogens with an electron on them each. And then we've got oxygen, and how many electrons are on or in oxygen's outer energy level? There's 8 total, but we only need to worry about the valence electrons for covalent bonds. How many valence electrons does it have? You can look back on your periodic table if you want. Jackie. 6. So we got 1, 2, 3, 4, 5, 6. How many electrons total does hydrogen want in its energy level? Dylan?
One more.
What?
One
Yeah, they both want 1 more. So 2 total for these 2, right? How many total does oxygen want? Tess? 8. Looks like we got a spot for 7 and 8 right here. So we can, what happens with covalent bonds? The atoms get close enough, and the attraction between the electrons and the protons from the oxygen atom draw them near to each other. So when they come together, it looks like this. I'll use different colors. I'm going to use, mark that up here. We've got the oxygen, which we said had 1, 2, 3, 4, 5, 6. Thank you, Becky. Then we had the hydrogens, which each have 1 that it now shares by a covalent bond. So right here is the one that's being shared. So this one now has access to these 2, so it's full. And the oxygen has access to these 2 to complete 8. So everybody's happy. Make sense? Okay. So that was covalent bonds.
There we go.
We are moving on now to ionic bonds. So covalent bonds, quick review, are bonds between what types of atoms? Covalent bonds only form between a certain type of atom. Devin.
Hydrogen.
Okay, hydrogen. Well, hydrogen is a type. Let me see, I'm pretty sure we have this in our notes. We don't have it in our notes in this class.
No, we don't.
Okay, we got to add this. Under covalent bonds. Covalent bonds only occur between nonmetals, 2 nonmetals. So if you notice our examples so far, we had hydrogen and hydrogen, both nonmetals. Hydrogen and oxygen, nonmetals. So covalent bonds occur. Do you want me to write it on the board as well? Okay. along with the definition of a covalent bond, sharing electrons, you can add a semicolon, and you can add between two non-metals. So covalent bonds only occur between non-metals. So let's review where the non-metals are found. We've got this huge section right here in the middle. We've got the stuff that's along, the elements that are along the red zigzaggy line. And then we have all the elements on the right-hand side. If you can't remember how we color-coded it, you can look back on page 10 where our periodic table is. According to that periodic table, those sections are, yes?
The ones on this side of the red.
Yes. So, non-metals are in this right-hand corner right here, right? These are the metalloids, and then that big section are all the metals. So covalent bonds really only occur between non-metals. But there's a lot more elements than just those non-metals. So how do they bond? Those are ionic bonds. So, yeah. What was that?
I was talking about that, like,
Is that what you were talking about on Friday? Was it you?
like it's like stealing one and then the
Yes.
one with no electron. and-
Yes, okay. Jackie's like, what? What are you talking about? Hey, ionic bonds. Those are the bonds that form when an electron is actually transferred. One atom gains an electron or more, and one atom loses an electron. And we saw a prime example of that in that video about elements, the periodic table video. Yeah, periodic table. Do you remember they showed us sodium chloride? And they showed us how the sodium, if you look back at that periodic table with the energy levels on it, it showed us how the sodium atom wants to give away that electron so that it has a complete energy level. And it gives it away to chlorine, who wants one more electron, and you end up with table salt, sodium chloride. Do you recall that video?
Yes.
Good. Okay. That's
They made popcorn.
They made popcorn. That's ionic bonding. So before we write anything down about ionic bonding, I'm going to show you some examples. Okay. Let's see. Go to the media. Here they have. I'm going to do this. It's a little better. When we saw it on the video, he had the chlorine gas in a canister, so you couldn't actually see it. So happens, right here on this side, we've got a tiny, tiny piece of sodium. Remember, the sodium looks kind of silvery. Remember they said it cuts like cheese, it's very soft metal. So there's the sodium right there. This container right here, chlorine gas. Notice it has like a greenish tint to it. Chlorine gas looks green. And then right here they have a pipette with some water in it. They're going to use the water to help expose some of the sodium atoms because all the sodium atoms are in this big, this little chunk right here, but they're very compact. So adding water helps them separate. By separating that, when they apply the chlorine gas, we should get what? Salt. So let's see.
Sodium.
Did not read there. This demonstration shown in this video is very dangerous. Do not attempt to perform this demonstration.
Doesn't sodium explode in water?
Whoa! Here we go. There's the gas. They put the gas in there. Or sorry, the sodium in there. Oh, he's saying something. We'll have to watch it a second time. I'm going to start it over so we can hear him. I didn't realize there's sound. Do you guys hear that? Here's the sound. That's
Hey,
helpful.
don't have my eraser.
Still in the ceiling, please.
Here we go, one more time. What's he saying?
A small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass.
Wow.
Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.
There it goes. Instant replay.
That's cool.
Alright. They're not going to show us the salt step one. So the reaction releases a lot of energy and salt is formed. Now what would that look like as an animation? Here we have sodium. Sodium on the periodic table is atomic number 11. So how many protons does sodium have at this time? 11. And chlorine has 17 protons. And we know that however many protons there are, that's how many electrons there are. So you can see here, sodium has its first energy level filled with 2. The second energy level is filled with 8. And the third energy level is filled with just that 1. It's hanging out there. Okay? Chlorine, first energy level filled with 2. That's the max. Second energy level filled with 8. And the third energy level is filled with 7. Now we know that atoms prefer to have filled energy levels. So sodium has 1, chlorine has 7. So what does sodium want to do with its extra electron hanging out there? Shaylee? Yeah, it wants to give it away. That's why it's so reactive. Now chlorine has 7. What does it want to do? It wants a full energy level.
What's equal?
Yeah, it wants to gain 1 in the worst way. So these two atoms work well together in giving and taking electrons. Let's watch this animation. You can see there's an attraction there. And the electron from the sodium is given to the chlorine. And then something changed. Let's watch it one more time to start. Right now, because the sodium has 11 electrons and 11 protons, and the chlorine has 17 protons and 17 electrons, their charge is neutral, right? The positive, 11 positive proton in the center cancel out the 11 negatively charged electrons. That makes sense, right? You have 11 positive, you have 11 negative. The overall charge is 0. Same thing for the chlorine. 17 protons, 17 electrons. 17 positive plus 17 negative is 0 charge. So when the sodium loses this electron, or gives it away, it's going to have 10 electrons. So if it has 11 protons and 10 electrons, what's the overall charge going to be of that sodium atom? Positive 1. It's positive by 1, right? It has 1 extra positive there. And then the chlorine has 17 protons, and when it gains this electron, and now it's going to have 18 electrons. What is its overall charge going to be? 18 electrons, 17 protons. Is it going to be positive or negative? We have 18 negatively charged electrons, 17 positively charged protons. The chlorine atom is going to end up to be, Dalton? Negative. So watch how that works again. Electron is transferred from sodium to chlorine. The sodium becomes positive, and the chlorine becomes negative.
Opposites attract.
And now, there's another term that we have to look at. The term ion. That type of bonding is called ionic bonding. But notice now it says, or is it, sodium becomes a positive ion instead of just the word atom. Ion means that the atom has a charge to it now. It's no longer just neutral. It's going to be either positively charged or negatively charged. So So the sodium turned into a positive ion, and the chlorine turned into a negative ion. These ions attract each other, and we get the compound sodium chloride. So far, so good? Okay, let's stop that.